Hello everyone, I'm Dr. Monica Sugani, Associate Professor in Environmental Sciences and Engineering in the Department of Civil Engineering, Manipal University, Jaipur. I'm also co-convener of PMGF program at Manipal University, Jaipur. In this module, we will discuss on treatment objectives. Sanitation often focuses only on the provisioning of physical infrastructure, toilets or latrines in order to increase the coverage of toilets or to look at the epitome of sanitation, ODF cities. But in order to provide tangible and sustainable sanitation, there is a need to focus on the entire sanitation chain. Now this module explains the treatment part of the sanitation chain. After following this module, on treatment objectives, you will be able to name different treatment objectives. Number 2, relate the health and the environment impacts to treatment objectives. And number 3, understand different levels of appropriate treatment depending on the end use. Now, this is F diagram. This explains the fecal-oral routes of contamination. The purpose of this figure is to highlight the role of safe sanitation systems as a primary barrier to transmission by showing the way in which unsafe management spreads excreta in the environment and the potential pathogen transmission pathways from a human host leading to disease outcomes. The 6 F words in this pathway represent fecus, fluids, feels, flies, food, and fingers. Through the fecal-oral route, pathogens cause the spread of diseases. Pathogens can be spread via fingers, flies, feels, fluids, and food. By identifying the fecal-oral transmission pathways, public health can be protected. 3 main important goals of sanitary engineering and fecal sludge management are: the main goal is protection of public health. Another important goal of fecal sludge management, which is closely related to protection of public health, is the protection of environment health. If the excreta is contaminating the environment, it is causing risk to public health. The third goal, which is important to meet whenever possible, is resource recovery. And this is closely tied to the first 2 goals. In resource recovery, fecal sludge is turned into products that can be a valuable asset with economic and environmental benefits. Historically, the most common use for fecal sludge has been agriculture. Research is being done on new ways to beneficially use fecal sludge, such as a biofuel or using black soldier flies to make animal protein. If it is not possible, then safe disposal is a requirement to achieve the first 2 goals. Now, these goals of fecal sludge management can be translated into 4 treatment objectives for fecal sludge. The number 1 is dewatering. Fecal sludge is typically over 90% water. Dewatering is used to separate this sludge into liquid and solid part, making it easier to handle and less expensive to transport, to compose, to incinerate, or to dispose of in a landfill. Dewatering is important because water is heavy and expensive to transport. Water in fecal sludge is also contaminated and so can easily contaminate the environment. It is also important in achieving the goal of resource recovery. Also important is stabilization. It is the process of converting biodegradable organic matter into more stable complex molecules. This is important for treatment as readily degradable matter consumes significant amount of oxygen during degradation. If it is directly discharged, this can cause environmental damage. For example, in a river, it would result in a rapid drop in the dissolved oxygen in the water. What happens when dissolved oxygen in the rivers decreases? This will create anaerobic conditions and can kill the aquatic organisms. Stabilization also results in nutrient stabilization as ionic forms are taken up into the organic matter, meaning they are not readily leached out and are available for the plant growth. Stabilization also results in reduction of the odor, nutrient management, and pathogen inactivation. The third objective is nutrient management. The three important nutrients, also known as macronutrients, are nitrogen, phosphorus, and potassium. During treatment, nutrients are not necessarily removed but transformed. Nutrient management means changing the form of the nutrients, for example, liquid or solid, inorganic or organic. But why is this change in form of nutrients important? It is important to prevent environmental contamination and for resource recovery options in agriculture. For example, nitrogen in an organic form, as in composting, can be directly applied to crops, whereas nitrogen in an inorganic form, for example leachate, could burn plants or leach into the groundwater. Environmental impacts from nutrients include eutrophication and algal blooms in surface waters and contamination of drinking water. In pathogen inactivation, recollecting our F diagram from the starting, the fecus contains high number of pathogens that are harmful to humans. Pathogens are bacteria, viruses, protozoa, and helminthes that cause disease. Thus, it is important to prevent direct contact or indirect exposure to pathogens for the protection of public health. The transmission cycle of pathogens can be interrupted by putting barriers in place to block transmission paths and prevent cycle completion. Fecal sludge treatment inactivates pathogens in various ways. These mechanisms will be described in detail in a later module on fecal sludge treatment, pathogen inactivation mechanisms. The appropriate level of treatment will depend on the resource recovery or disposal option. For example, if fecal sludge is to be used as a fuel in combustion, the number one objective is dewatering to increase the fuel potential. In this case, lower levels of pathogen inactivation are acceptable as the fecal sludge will be incinerated. If fecal sludge is to be composted and used for food crop production, pathogen reduction is the main goal. The treatment objective should always be linked with the end use to ensure the protection of public and environment health. The first barrier for beneficial use is provided by the level of pathogen inactivation achieved through the treatment of fecal sludge. A selection of further post-treatment barriers prior reusing treated solid and liquid streams may include treating sludge to reduce pathogens to a safe level if used in agriculture, especially if people are going to eat uncooked crops. For pellets used as fuel, pathogen transmission is also important, but maybe in that case it only means protective clothing for workers while they handle the pellets. Other barriers can also be put in place to reduce the risk of pathogen transmission, like crop restrictions. For example, above ground crops like fruit, trees, application techniques, protective equipment, waiting period, and food preparation. Now, when considering the risk of infection, all the potential exposure groups should be accounted for, which can be broadly categorized as workers and their families, the surrounding community, and the product consumers. For more information on a multi-barrier risk-based approach. For protection of public health, I recommend the WHO guidelines for the safe use of wastewater, excreta and grey water 2006 and the WHO Sanitation Safety Planning Manual for safe use and disposal of wastewater, grey water and excreta 2015 and the Sanitation Safety Planning Module in SENDAC MOOC on Planning and Design of Sanitation Systems and Technologies. To summarize, in this module, you learned 4 different treatment objectives: dewatering, stabilization, nutrient management and pathogen inactivation. Why and how they are all important to achieve public and environment health, and that appropriate levels of treatment will depend on the intended end uses. Thanks for joining. See you next time.